For this lesson, we're going to be focusing on the idea of dividing polynomials. This is really a mechanical skill that we're doing in advance of the broader skill, which is going to be factoring generic polynomials. We've already done factoring for things like quadratics, so this is to step it up another level. Now, to lay a foundation for this, I'm actually going to remind you of long division, just using integer values or actually using whole numbers. And this would be the type of division that you would have started with when you were in elementary school. So many, not necessarily everybody, will have done this the exact same way, but most of you probably learned to do this by asking yourself, how many times does 4 fit into 107? And then you go through the process of saying, okay, does 4 go into 1? No, 4 does not go into 1. So now we ask, does 4 go into 10? Yes, 4 actually does go into 10, and so it goes into 10 two times. 2 times 4, we multiply this way, and then the result goes down here. 2 times 4 gives me 8. 10 minus 8, so now we subtract. 10 minus 8 is equal to 2. Now I bring down this 7, 27. Does 4 go into 27? Yes, it does. How many times does it go into 27? It goes into 20, sorry. How many times does 4 go into 27? It goes in 6 times. 6 times 4 is equal to 24. Once again, we subtract. In this case, we end up with a 3. There's nothing left, so that means that 3, that is remainder 3. That's what's left over. And if we were to then write this another way, 107 divided by 4 is the same as, is equivalent to the number 26. 4 goes into 107 26 times, and we have 3 left over, but that 3 was an attempt to divide by 4. As you can see, this is the same thing as the mixed number, which is actually how we arrive at mixed numbers, 26 and 3/4. 26 and 3/4, 26 plus 3/4, they mean the same thing. So we're going to be focusing on this form, and we're going to take it one step further, which is now we want to introduce the idea of a polynomial, something that has variables involved. So that may seem like a pretty big step to go from what I just showed you to this, but it's, when you break it down, it's actually not so different. So let's start off. I want to know, how does this factor x minus 3 fit into 3x cubed minus 5x squared minus 7x minus 1? Now when you do this, you're going to want to make sure that you have this in descending order of the powers of x. And something that will come up with, I'm sure we're going to run into this with some homework questions, that sort of thing, but I strongly recommend you make sure you actually have a 1 at a time, a delta of 1 for the exponents. So if you were missing, for example, if you were missing the x squared term, I would actually put a 0x squared here. You don't have to do that. There's something to be said for doing it. And hopefully later on we'll look at examples that will hopefully show that to us. But that's not part of the lesson. That's something that we'll talk about later. So now I ask myself, what do I have to multiply by? And what I'm going to do is I'm actually going to start by focusing on these first terms. So what do I have to multiply by x to get 3x cubed? And the answer to that is I have to multiply 3x squared. So 3x squared times x gives me 3x cubed, but I have to finish the rest as well. 3x squared times negative 3 is going to give me negative 9x squared. So I have to do both of those because there are 2 terms here. I have to multiply by the 2 terms. Now, something else that comes up here is, I'm not sure, how did the book, yeah, the book represents it. You could also have written this 3x squared here. which I actually prefer now that I think on it a little bit more, because it lines up with, it's an easy thing to remember because the exponents line up. So I need to multiply by an x squared here, so I'm going to write my first term here. So 3x squared times x gives me 3x cubed. 3x squared times negative 3 gives me negative 9. Now I'm going to subtract. So I subtract 3x cubed minus 3x cubed gives me 0. Negative 5x squared minus negative 9x squared is like adding 9x squared. That's going to give me 4x squared. And I've got two terms that I'm working on here, and I want two terms to work with. So I bring down the negative 7x. I've got two terms, and again, notice that the exponents are separated by a difference of 1. So now I ask myself, I need to eliminate this x squared term. What do I multiply by this x to get rid of this x squared term? Well, that's going to be plus 4x. 4x times x is 4x squared. So when I subtract that, that'll go away. Positive 4x times negative 3 is negative 12x. Subtract becomes 0. Subtract becomes 5x. And last step, I'm going to bring down this negative 1. And so what do I multiply by x to get 5x? Well, that's just multiply by positive 5. 5 times x gives me 5x. 5 times negative 3 gives me negative 15. Subtract gives me 0 here, gives me positive 14 here. So that is my remainder of 14. There's nothing left for me to do here. Now, to put all of this into perspective, here's the mechanical part, but at least as important as this is to understand what is this really meaning. So I'm going to rewrite this. First of all, I'll write this division as a fraction. 3x cubed minus 5x squared minus 7x minus 1 divided by x minus 3. So we tend to do our division using a fraction. You're not going to see this divided by symbol very often. It's not particularly useful. It's useful for being able to express something on the same line, perhaps. Okay, so what is the answer to this? Well, we've answered it, but now how do we represent that answer? Well, the answer to that is here. 3x squared plus 4x plus 5. And that, just like here, that's the whole number part, but we have to also address the remainder. The remainder was positive 14, so that's going to be plus 14. But what were we trying to divide by? It's not just plus the number 14, it's plus it's plus 14 over x minus 3. This factor that we're dividing by is still here. So these two things are equivalent to each other. So when I divide by this polynomial, when I divide this polynomial by this factor, there is a polynomial plus there is this part left over. Okay, now there is another way to do this, which is called synthetic division. And in your textbook, that's on page 164. Synthetic division is simply a shortcut method. It's a little bit more efficient as far as writing stuff. It gets you to your answer a little bit more quickly, but it carries with it the risk of being unfamiliar. Hopefully most of you or all of you are familiar with the idea of long division, but it also changes the rules a little bit to achieve that increased efficiency. Now, one of the things it gets rid of is we don't bother writing out these x cubed, x squared, etc. It requires that you have every term represented. So again, I've mentioned this before. If you're missing, for example, if you were missing the x squared here, you would still write in a 0x squared. And so the first thing I would do is I'm going to write those values. 3, negative 5, negative 7, negative 1. And make sure you space them out, okay? Give yourself a little bit of room. And then we do something like our long division sign, except for it looks a little bit different here. And then the other thing is whenever we write factors, particularly when we're dealing with factored form, we would normally write x minus r bracket x minus s bracket x minus t, etc. And so these are typically in the form x minus k, x minus something. So in this case, if this is in the form x minus k, then what is k actually equal to? It's equal to positive 3. So it's that idea of changing the sign. And that's what I put here. Now this came from x minus 3. So the x is still there. The x is still important. So this first value doesn't change because this value, just like we did here, it got applied between this x and it was to deal with this first term. So the number, this number always comes down and it's just a 3. So that is always going to be how you start with this. This first number will be the first number here. 3, and this is a 1. This has to be a 1. 3, 1 gives me a 3. Now, this is where things, as if things haven't already gotten complicated enough. So this number 3, so what we do is we multiply this by 3 and we put it here. So 3 times 3 is 9. And just to add yet another wrinkle to what we're doing, we add. So instead of subtracting like we did before, we're adding when we do these. And if it helps you, the same way, see how we reversed this from a negative 3 to a positive 3? That is why we're adding now instead of subtracting. Okay, so positive 9, negative 5 plus 9 is equal to 4. Then I take that value, multiply by 3, and 4 times 3 gives me 12. Negative 7 plus 12 is equal to 5. Take that value, multiply by 3. Remember, I'm adding here. 5 times 3 gives me 15. I add those together. That gives me 14. And this is my remainder. So these three pieces together. So we started with a cube, and this x is at the front. Actually, the other way to think of it is this is always a constant. So this is always the number. In this case, this is 5. And that means this would be a 4x. This one would be a 3x squared. And then this is my remainder, 14 over x minus 3. So that would be the answer. So this is equal to that. And you can see I've done this using a lot less space. And the way that I was able to get rid of all that extra space was there's a lot more thinking in here. And there's a lot, I've taken away a lot of the visual cues that help me keep things straight. I will be perfectly honest with you, despite the fact that I am comfortable with all of the mathematics that we're looking at with this. In general, unless I'm doing something truly huge and horrific, I would prefer to do this in most cases. Just as far as being able to go through this error-free, I think you're more likely to have success with that. But it will be your preference. Okay, so if you are doing synthetic division, the divisor has to be in this form, x minus k. The one x is important, and then you have to remember k equals whatever. You have to be able to pull out your value for k. Both of those things matter. All terms have to be represented, even if they have a coefficient of 0. So for example, you might have 3x cubed plus 0x squared minus 5x plus 0. So even though this was just 3x cubed minus 5x, you had to include the 0 here and the 0 here to make sure that everything had a term where it lines up. If the root is k, so it's x minus k, so that means a root is k. If you've got a fraction, Long division, again, this is another case where long division is probably going to be your preference. I'm actually going to show you an example here of what it looks like if the root is a fraction. And if we do our division, whether it's long division or whether it's synthetic division, if we do our division and we end up with a remainder of 0, that means the division worked perfectly, and that means that you have found a factor. Okay, right now it's just a divisor. But if the division works perfectly, then you actually have a factor for that polynomial. And that's going to be something we're going to cover in a lot more detail in the next lesson, where we look at factoring as an entire lesson. Okay, so now, in this case, I'm telling you it's a factor. So that means the result of this division is going to be 0. There's no remainder this time. So I'm telling you 3x plus 2 is a factor, but we're going to show that as well when we do the division. And I want to determine what the other factors are using synthetic division. So I'm kind of forcing this synthetic division, and I'm forcing it in a very awkward place. And I want you to see how awkward it can be. Okay, so the first thing is that for synthetic division, we need something to be in the form x minus k. So how do we take 3x plus 2 and put it into that form? Well, the way you do it is you need to factor out this 3 from the front, and that leaves me with an x plus 2/3. Now, we're going to be doing our work with 2/3 here, and I know how thrilled many of you will be with the idea of having to do fractional arithmetic. If you did long division here, you don't have to make this change. You can just work with 3x plus 2. So there's a bit of a selling feature there. Okay, now let's take a look. I've got an x cubed squared to the power 1 and to the power 0. So I don't have to add any terms. I don't have to put in any 0 terms. So I can just go ahead and write 6, 19, 1, and negative 6. I then take, don't forget, this means that k is equal to negative 2/3. Right? It's x plus 2/3, so the k value is actually negative 2/3, and I'm going to put that there. First step, we always just go ahead and use this value, 6. Then I take 6 and I multiply by negative 2/3. 6 times negative 2/3. Obviously, you'd like to do this in your head if you can. So we end up with negative 12 over 3, which is equal to negative 4. So I get a negative 4 there. I add these together, I get 15. Now I'm going to do 15 times negative 2/3, and that's equal to 15 divided by 3 is 5, times negative 2 is negative 10. Negative 10, and I add those together, I get negative 9. Negative 9 times negative 2/3. Negative 9 times negative 2/3 is equal to negative 9. Actually, negative is going to be positive. 9 divided by 3 is 3. 3 times 2 is equal to 6. And I get 6. I add those together. That is my remainder. My remainder is 0. And that's what I said would happen, because I told you that 3x plus 2 is a factor. That means your remainder is equal to 0. That's what it means to be a factor. Okay, so let's make sense of this. This is negative 9. This is a constant. This is an x. This is an x squared. So our answer, another way that we can write this, what we're saying is, so first of all, let me just go ahead and write that out. 6x squared plus 15x minus 9. That's just this part right here. Now, let's figure out what we did here. We did 6x cubed plus 19x squared plus x minus 6. And we divided it by 3x plus 2. And we found, well, hold on. No, we didn't do that, did we? This is the whole reason why I wanted to write this out. What did we actually do? We divided by this x, right? When I did this part, this is only doing the x minus k part. It's ignoring this 3 in front. So far what we've done is we have divided by x plus 2/3. And my answer to that was 6x squared plus 15x minus 9. But 3x dividing by 3x plus 2 is not the same as dividing by x plus 2/3. It's the same as dividing by 3 times x plus 2/3. So in order to introduce that divided by 3 part, I have to divide both sides by 3. Now in this case, the numbers actually work out nicely. So 6x squared divided by 3 is 2x squared. 15x divided by 3 is 5x. Negative 9 divided by 3 is negative 3. But you have this extra step here, this extra piece for you to have to remember, as if the pieces in synthetic division aren't enough to remember as it is. And as is always the case, we have to make sure we've actually answered the question, because it says, given that this is a factor, determine other factors using synthetic division. Now, once you get down to a quadratic, I certainly don't expect you to use synthetic division anymore. But at this point, you've got a quadratic, so you're probably going to use SPI to come up with that one. Sum, product, and integers. The sum is equal to 5. The product is equal to negative 6. What are two numbers that add to negative 5 and multiply to negative 6? That's 6 and negative 1. So we end up with 2x squared plus 6x minus x minus 3 is equal to 2x times x plus 3 minus 1 times x plus 3, which is equal to x plus 3, 2x minus 1. And so from this, I can see my factors are 3x plus 2 is the one that we were given, x plus 3, 2x minus 1. And if you wanted to, you could multiply all three of these out and you would end up all the way back at our original value. I think that ended up being a little longer than I was anticipating, but all very important work. Lots of practice here. It's important that you do this practice. You will always have the choice between synthetic or long division, but you need to figure out which one works best for you. And you want to make sure that you practice both of them. You can't figure that out unless you try.